Hello and welcome to the second video. So we're still just doing algebraic expressions. This is a prelude to the A-level proper, if you like. This is almost like a warm-up chapter, hence chapter 0. So like you saw before, there's 4 warm-up questions for you to get used to. This topic is going to be mainly about factorising expressions. The first lesson was expanding. Now we're going to have a look at factorising things. So have a look at these warm-up questions. Try them yourselves. Press play only when you've tried every question to the best of your ability and see if my solutions match your own. So let's have a look now at question 1. So question 1, we need to, for these set of numbers, find all factors and then the highest common factor. And so let's have a look first of all now at part 1, 18 and 24. And so what I'm going to do now is go back to GCSE times and do a factor bug diagram. Not the fancy proper name for them, but it works for me remembering what it is. So start with the smallest number you can divide 18 by, which is obviously 1. You can divide any number by 1. On the other side, put down the answer to that. 18 divided by 1 is 18. The next number you can divide it by is 2, which is 9. We can divide 18 by 3. That gives us 6. Can't divide by 4. Or 5. We can divide by 6, but we have this on the other side, so that shows we've got all the factors. We now do the same for 24. We can divide 24 by 1, which gives us 24. We can divide it by 2, that gives us 12. We can divide it by 3, which gives us 8. And we can divide it by 4, and that gives us 6. We can't divide it by 5. We can divide by 6, but we already have 6 on the other side, so we have all the factors. So let's have a look now at the common factors, the factors you can see in each. So 1's a common factor, as you'd expect, as is 2, as is 3. 4 isn't, but 6 is. 8 isn't, 9 isn't, nor is 12, nor is 24. So for the first one, the common factors, we've got 4 of them. So starting with the smallest, we've got 1, 2, 3, and 6. So the highest common factor, the HCF, is the highest of these common factors, which obviously is going to be 6. As a general clue, the highest common factor of a set of numbers, or 2 numbers, is going to be a factor of the gap between the numbers. So the gap between 24 and 18 is 6, so the highest common factor must be a factor of 6. 6 is a factor of itself, so in this case, the highest common factor just happens to be the gap itself between the numbers. So the highest common factor of these is 6. Same thing for question 2. If you can spot the trick here straight away, that's a bonus. But I'll do it the long way. Factors of 25. We can divide 25 by 1, which is 25. We can't divide it by 1, 2, or 3, or 4, but we can divide it by 5, which gives itself. That's why 25 is a square number. We can divide it by something, which gives the same answer. 25 divided by 5 is 5 as well. Also as well, it has an odd number of factors. If a number has an odd number of factors, it's a square number, unless you're talking about, no, every single number which has an odd number of factors is a square number. Getting myself confused there for a second. So 26. 26 we can divide by 1, gives us 26. We can half it, we can divide by 2, which is 13. We can't divide it by 3, we can't divide it by 4. Can't divide it by 5, or 6, or 7, or 8, nor 9, nor 10, nor 11, nor 12. But we can divide by 13, which we already had on the other side. And so this is all the factors of 26. So common factors, this won't take us too long. The only common factor we have, I'll do that in yellow actually, the only common factor we have is 1. Therefore, that must also be the highest common factor. It's the only factor, in fact. So common factor, just have 1. So the highest common factor is just 1. Question 2. These are algebraic expressions. Find the highest common factor of all of these. So do the number first and then the letter or letters. So first of all, 14 and 2. What's the highest common factor of 14 or 2? That's going to be 2. Then we have x and x squared. So what's the highest common factor of x and x squared? That's just going to be just x itself. And so the highest common factor of these two terms must just be 2x. Down for part B, the highest common factor of 16 and 20 would be 4. Look at the x's. We have 1x here, x times x here, so the biggest number of x's in each term is just x. Similarly with the y's, we've got y times y here, but just one y there. So the highest number of factors, the highest number of y's in both, is just y. So that's 4xy, which is the highest common factor. Highest common factor of 17 and 18. Well, the gap between these numbers is just 1, so the highest common factor of 17 and 18 is just 1, which we don't need to include in an algebraic expression. Highest common factor of x, well, we've got x times x here, but no x's at all over there, so we don't have any x's common to both terms. Common to both for the y's, we've got one y here, y times y over there, so there's only one y common to both. And the z's, z multiplied by z here, just one z here. So only one z common to both terms. So the highest common factor for this one is just yz. We don't need to put one yz, just yz. Warm-up 3. Expressions for the length and width of this whole rectangle in the diagram below. The big clue here is we have an x squared. So what two things would multiply together to give us an x squared? It has to be an x on top and an x to the side. So that's our way into tackling this. Next we can think about, well, either 3x or 2x in any order really. So let's have a look at 3x. That means 3 multiplied by x. We've got the x already, so this must be a 3 above. X times 3 gives us 3x, so that's that one sorted. Down here we have 2x. Which is x multiplied by 2, and then the 6 checks out as well. 2 multiplied by 3 is 6. So we worked out the length of it is x plus 3. The width of it, going downwards, is x plus 2. How do you work out the area of a rectangle? Well, it's the length multiplied by the width, which is x plus 3 multiplied by x plus 2. Which, if you multiplied it out, would give you this thing here. We'd have x squared plus 3x plus 2x, which is plus 5x plus 6. I do realise the question didn't ask you to do what I've done here. I just wanted to show you how it links in nicely, the picture versus the algebra. So length times width, we can make a geometric link to the algebra by setting it out in this diagram. Finally, for the warm-up, question 4, 2x plus 5y expanded by 2x minus 5y. So let's expand it out the slow way first, see if we can spot a link. 2x multiplied by 2x, 2 times 2 is 4, x times x is x squared. Then 2x multiplied by minus 5y. 2 multiplied by minus 5 is minus 10. X times y is xy. Then if we have a look at expanding with a 5y, 5 times 2 is positive 10. Y times x, x times y, same thing as just x, y. And then 5y multiplied by minus 5y, 5 multiplied by minus 5 is minus 25. Y times y is y squared. So we have here minus 10xy's first and plus 10xy's over here. They're going to cancel each other out. The only thing we're going to be left with is just 4x squared minus 25y squared. You should have seen this before. What sort of thing is this? What's the square root of 4x squared? Square root of 4 is 2. Square root of x squared is x. What's the square root of 25y squared? Well, the square root of 25 is 5. Square root of y squared is y. This is, as you should know, an example of the difference of two squares. We're going to see this in some of our worked examples where we're going to be factorising terms. So first of all, let's get straight into it and try and factorise these. Factorise completely. So we're going to go for the highest common factor each time. So do the numbers first, then consider the letters. So there's no x's common to each here, but there is a common factor of 3. Once you've wrote down all the common factors, we then put the brackets in. We want to end up with 3x. We've got a 3. What do we need to multiply 3 by to get 3x? Obviously that's just an x. Plus, so put a plus. We've got a 3, we want 12, so we need to multiply this 3 by 4. So the first one is 3 lots of x plus 4. For part B, we have no numbers common. Suppose we say that's a 1, x squared, but everything has a highest common factor of 1, so it's not even worth mentioning, so we don't need to include that one. However, we do have a common factor of x. So we've got x. Now we need to think about how we get x squared. We get x squared by multiplying this x by another x. We've got an x here. We want to end up with minus 2 x's for the second term. So what do we need to multiply x by to get minus 2 x's? That's just going to be multiplied by minus 2. And so that's B complete. For C, do the numbers first, the coefficients. We've got 2 here and 14 there. So what's the highest common factor of 2 and 14? It's going to be 2. Next, think about the letters. We've got x's in each, but only one x over here, so the highest common factor for both terms is just an x. We've got all the common factors exhausted, so now we put the brackets in. We have 2x, we want to end up with 2x squared. The 2's sorted, but we need to multiply the x by another x to get 2x squared. So that one now is okay. Next up, we want to go from 2x up to 14x. So what do we need to multiply 2 of these x's by to get 14 of them? We need to multiply the 2x's by 7. 2x times 7 gives us 14 x's, so we've sorted this term out too. Finally, part D, highest common factor of the numbers first. So what's the highest common factor of 16 and 20? That's going to be 4. Now the letters. We've got 1x here, x times x over here, so only one x is common in each. Any other letters in each term? Well, yes, there's also y's in each. 1y here, y multiplied by y there. So the highest number of y's in each is just for 1y. Now we're done. So open up the brackets. We've got 4, we want to end up with 16. So we need to multiply this 4 by another 4 to get 16. X's are sorted already. Y, we need an extra y to get y squared, so we must multiply this y by an extra y on the inside. Minus, so write down the minus. We want 20, we've got 4. So we need to multiply this 4 by 5 to get this 20 here. We've only got one x, we want x squared. So we must multiply this x by an extra x on the inside. Meanwhile, the y's are sorted. We've got 1y, we need to end up with 1y. So don't multiply by any other y's, otherwise we'll get y squared's cubes. So just leave it as 5x there. And so then we've finished off section D. Worked examples for the second set. We're going to be factorising these quadratic expressions and cubics without a constant term. So this just takes us back to GCSE. If we're factorising quadratics where the coefficient of x squared is just 1, we just need to think of two numbers that multiply to give us minus 18, but when they add them together, gives us positive 7. These two numbers are 9 and minus 2. So in any order, we put positive 9 and minus 2. Simple as that. For part B, the coefficient of x squared isn't 1. So we need to use what I call the AC method. So we multiply the coefficient of x squared, which is 6, by this constant term, which is minus 5. 6 multiplied by minus 5 is minus 30. So what we need to hunt for here is two numbers that multiply together to give us minus 30, but when we add them, we get this number 13, positive 13. So minus 30 by multiplying these two, and 13 because of this number here. So have a think for a second. The two numbers we're after, I'm hoping you can see, they're going to be 15 and minus 2 in some order. You could use your calculator to do this, but for now, at such an early stage of the year, let's just focus on the algebraic skills. We can worry about the calculator skills after. So 15 and minus 2. What we now do is we partition this 13 into 15 and minus 2. So we rewrite it 6x squared plus 15x minus 2x minus 5. Now each term here, each pair, will factorise again. And so 6x squared and 15x, that has a common factor of 3 and an x. So we want 6x squared, so multiply the 3 by 2, multiply the x by another x to get by x squared. To go from 3x to 15x, we must multiply by 5. Next, this pair will factorise. Both terms are negative, so we have a common factor of minus 1. Minus 1 multiplied by 2x gives us the minus 2x we need. And minus 1 multiplied by positive 5 gives us this minus 5 we need. Now if you have a look at what we've got, this bracket here is duplicated itself. So we've got 3x lots of the brackets over here, minus 1 lot of this bracket over there. So in total, we've got 3x minus 1 lots of this 2x plus 5 bracket, and then we're done. Essentially, all that happens, after this bracket duplicates, the things before the bracket form their own first bracket before it. 3x and the minus 1 come together into a bracket before the 2x plus 5. For part C, we need to be thinking about this a bit carefully. So 9x squared and 25. The big clue is the coefficients. What type of numbers are 9 and 25? The square numbers. X squared is x squared, obviously, and y squared is y squared, obviously. So these are two square terms. So this is actually one square thing minus another square thing. This is an example of the difference of two squares. This is an example of this thing here, a squared minus b squared. This is the general formula, by the way, of difference of two squares. It's always a plus b, a minus b, where in our case, a is this thing here square rooted. Square root of 9 is 3, square root of x squared is x, and our b is the square root of all of this. Square root of 25 is 5, square root of y squared is y. So what I'm saying here is that 9x squared minus 25y squared can be factorised into 3x plus 5y, close brackets, and then 3x minus 5y. Finally, moving on to part D. Hopefully for part D, it looks a bit more confusing. It's a cubic, but if you notice carefully, here there's an x in each of these terms, so we can factorise out an x first of all. So we have x brackets, x times x squared gives us this x cubed we need. X multiplied by a minus x will give us this minus x squared we need. And then x multiplied by minus 12 will give us the minus 12x we need. So now look at this bracket here. We can imagine this minus x as being minus 1x, if we so wish. So then, because the coefficient of this x squared is just 1, it's very similar to part A. So we need to think of two numbers, if we can, that multiply to give us negative 12, but when we add them, give us negative 1. Have a think, but I'm hoping eventually to stumble on the fact that these numbers are positive 3 and negative 4. And so this part here, this big bracket, factorises into these two separate brackets, and then we're done. So now it's over to you. If you could try these questions yourselves on question in exercise 1C on page 8 of the blue pure maths book, just these questions in particular, so you should try every single question, just these particular question parts, that should give you a grounding and a warm-up into the skills you need to be really fluent with for this A-level course. So try all of these first. If you get stuck, ask me in class or send me an email if you're not in class or can't reach me. If that all fails, send me a message on the comment section of this video. But whatever you do, don't just ignore it and think by hiding under some blankets your maths problems will magically disappear. They won't. It needs your hard work. By the way, with each of these videos, you should see at the bottom there are timestamps so you can jump to any particular section of the video you want to have a look at, rather than having to just sit through the whole recording, which you might find quite boring. So thanks again for listening. Be in touch with me if you are stuck, and you'll see me soon. Thank you again.